It's live now.
Okay. Thank you. So we will start at 2:30. Let's wait for 5 minutes. Make me the host. Can you make me the host?
Yes, I
Yeah.
did that.
Yeah. Thank you. Thank you. So let me. Hope my this camera is visible to all of you, and this is my code. Okay. Okay, so hello everyone. Welcome again for in new sessions regarding the new topic on the IoT security system. So, like in your IoT devices, we all use in day-to-day life, like from the lamp, a smart lamp, to the smart television, to the smart fridge, or to the any kind of IoT hub, or even in the industrial IoT. But one main thing in any kind of IoT device that we concerned about the data privacy and the data security. So data security is one of the main concern for many of the IoT engineers and many of the developers, and that need to be tackled. That need to be tackled in a good way. That need to be tackled, and that need to be uh, that need to be make it little bit more secure while doing the communication. So even though suppose that if some kind of any kind of hackers even though try to get some of the data packets that you are sending in between the devices, and even though if they got that data, it need to be encrypted so that that data, even though that data get leaked, the it can't be readable to the most of the people, or not be readable to the people who are trying to intercept the data. So even someone intercept the IoT data, it should not be leaked what the data inside that. We originally do it using the encryption chip. So in many kind of IoT devices, this encryption chip is needed. And but if we go for the DIY kind of things, or if we go for the daily life of equipment that we make by our own self, IoT devices that we design by your own, we often miss this layer, the IoT security layer. We didn't encrypt the data. And even though if you encrypted the data, there is another security layer. What if I have encrypted this data? I have added all kind of software to the chip, so that data can't be leaked. No one can join the network. No one can steal the data. No one can intercept the data. But even after doing all these kind of software thing, what if someone change the firmware of the chip? What you will do? Suppose that you have a smart hub that can control the IoT hub that can control the light in your room and everything, and it is totally secure. It has into encryption system. It has password system into everything. But I came to your home and I take the chip out from your box and reprogram it my firmware. Now I can control your device because whatever the software that layer that you have, I have reprogrammed that chip with my software. So I can control your home using my every data security layer got breached here. Every security layer on the software layer that you have added to the device is now bypassed. So how you can protect them? Any idea you have? So you can write me in the comment. I will check it right now and tell then I will tell let you know how you can protect yourself with such kind of technological bits. So there are different kind of security layers in the IoT system that mean to add the hardware layer, the software layer, the data encryption, decryption system, and many things. Okay, so in today's session we are going to talk not going to talk about the hardware layer. I will give you a little bit intro about the hardware layer. I'm going to talk about the software layer as well. Okay, most of the topic is regarding the software layer. Okay, so for any kind of IoT device, okay, for any kind of IoT device, the encryption is the main concern for the chip. How you can encrypt the data while sending between the devices. Like you have a smart EV vehicle, or you have a smart automotive vehicle, where the every data of your automobile, how much you have run, what the condition of engine, what the fuel, every data is you are using the IoT chip on the vehicle, and that data is being sent to the you or any kind of manufacturer. And if some other one people want to intercept that data, then how you can make that data secure as well? In the industry, you are transferring the data of many chemicals or many equipments in your factory. So how you can make those data secure? So data encryption here takes part here in that thing. But in most of the cases, like if you want to encrypt the data and decrypt the data, there are special kind of security chips are there. Okay, they are called they are called crypto chips. Okay, encrypting chips. These kind of encrypted chips out there in the market, like one you see here in my screen. I hope my screen is visible. So these kind of encrypting chip are needed with your IoT device so that you can encrypt the data. These specialized chips handle the encryption keys, store the encryption keys, and then encrypt your data, decrypt your data. So the both things need to be done. The device that is sending the data need to encrypt the data. That device that is receiving the data need to be decrypt that data so that it can extract the original message. And all these things done with during using the encryption and decryption chip. So if you are using the any kind of IoT device and they not come with the inbuilt encryption chip, then you can use this kind of encryption chip in the market that comes in various prices based on the specifications. But here I am using the Indus Board coin. You can see here I am using this Indus Board coin, and on this Indus Board coin, the encryption chip decryption chips, eFuses, and many other security layers are already inbuilt inside this, inside it. So you not need to buy any other encrypting chip. You not need to add any kind of encrypting chip to this device. It's already integrated into. There is a eFuse, and there is a eFuse ID on the various layers of the hardware. So no one can reprogram the chip if you can break that eFuse inside this Indus board. Every Indus board comes with the unique eFuse, okay, and eFuse ID. So suppose that if you are giving this device to some kind of client, and you want to make it secure that no one can breach the firmware that you have put in the board, then you can simply burn the eFuse inside the chip, and then no one can reprogram it. Okay, so that is another security layer. Then it has a TRNG, that is the true random number generator as well. TRNG is the OTP. You might have used the OTP in the day-to-day life. So TRNG is a true random number generator. RNG is the random number generator. So it's already there in the chip. So first, let's talk about the encrypting the data. So as I've told you, for this board, the Indus board coin board, this board has inbuilt encrypting chip, so you can directly encrypt and decrypt the data, and you can make your IoT secure while transferring the data or receiving the data. And you can add the end-to-end security layers in the WhatsApp, in the Facebook Messenger. You might seen the end-to-end encryption chat. So you can make such kind of things using this, because it's already inbuilt. If your IoT system do not have, if you have any other board other than this, like other board, Arduino one, and if that particular board do not have the encrypting chip, then you might need to buy the encrypting chip and add this kind of encrypting chip and add to your device for the encryption of the data. But here we already have the chip, encrypting chip. So let's try to use the encrypting chip that is already integrated in this board, and try to encrypt the data and then decrypt the data. Okay. So for the encryption, so you can not only learn using this board, you can not only learn and do the design the device, but you can also make a security layers. You can also learn about the security system in the IoT as well, just using this board, using this smart board, because everything is already integrated that you need for the IoT system. Okay. Yeah. So the encryption chip that is presented inside the board, we are going to access it. But before that, let me show you the demo. So suppose that this is the code I have made for the encrypting of data. So whenever I plug it this board here, let me show you side by side. Whenever I plug this board, and this side, let me open this. So as you can see here in the serial monitor, let me enlarge the serial monitor. So as I connect this board, okay, in the serial monitor, you will see the message on the encryption and decryption firmware is already integrated in this board. I will tell you later. But let me show you the demo. So as soon as I plug this board here in this serial monitor, you can see send the command en to encrypt the message, and dp to decrypt the message. Okay, so suppose that I want to encrypt any kind of message before sending to the device, any kind of client or any kind of other person who is running the same firmware on the other side of the device. Okay, so suppose that I am sending the message, hello, I am ASHWSWINI, and my secret password is 123 whatever this is. This is my secret password. So I want to encrypt this message before sending it, so that even though while I'm sending this message in between the one IoT device to the another IoT device, if someone intercept the message in between, and those hacker intercept the message, or theft out the data packets in between the transmission. So even though that person uh, intercept the message, they can't read that message because that is encrypted. He can't read what I have sent. So this is what the use of the encryption. So here I have first I need to send the command whether I want to encrypt or decrypt it. So I am sending the command en to encrypt the message. Now it will ask me to write the text to encrypt it. So earlier message I am typing here. Now I hit enter, and now my message is encrypted. See, this is my encrypted message. You can't read it. See, you can't read this message. This message can't be read. So if suppose that I am sending some kind of message that is that need to be secure, that need to be that not need to be disclosed, or any kind of sensor data, the important sensor data in my factory that I need to sending to the one device to the another device. And if any hacker try to intercept that data, so even though if he succeed in intercepting the data and retrieving the data packets from the Wi-Fi signal, he will get this message that he can't read what it is because the data is encrypted. So now if I want to decrypt the data, the other end of the device that is receiving the data, so that can decrypt the data. I just simply send the command dp to decrypt the data, and now I put this message. Now it will show me the decrypted data. See, it decrypted the message. I am Aswini Kumar sir. I am sending this thing. I have sent this thing. Okay, on the other end of the device. Or if you have any other data, DP. So here I have the another data that is encrypted. Let me show you. So this is the encrypted data. You can't read it. What is it? It is encrypted data. It is this data is encrypted. You can't see what is this A, B, C, D, 566. What is this? I can't, even though I am sending this data to the person, to the another IoT device, or to any kind of person. And if any if any hacker, black hat hacker or white hat hacker, whatever the hacker is, intercepted that data packets between the Wi-Fi signal, and if he intercept that, he will get this message that he can't read because it's the encrypted. Now the on the other end, the device running the same firmware with the same encryption key can put this message. Now he will get the original message. So only the device, only the person who sent the data, device who sent the data, and the device who received the data have the encryption key and can encrypt and decrypt their message, and can read the message in between. And if anyone intercept the message in between the transmission by any white hat hacker or black hat hacker, they can't able to read the message. Okay, this is the purpose of the encryption and decryption. And we can all do all these kind of encryption and decryption because the encrypting chip and decrypting chip is already present in this board, okay, already present in this board, okay. So let me show you how you can use the encryption key and decryption key in the encrypting chip inside this board, okay. So the process that I am using here is AES encryption system, AES encryption system. Okay, there are many kind of other encryption system are also there in the market, but here I am using the AES encryption system. That is a 32-bit AES encryption system. So that store the 32-bit unique key that I will generate. Okay, this key belongs to me. So remember this point while making the encryption and decryption. The key, encrypting key, there are certain sets of the words or the numbers or hexadecimal binary hexadecimal number or binary codes are there. The encryption key number. So everything that I will write, the message that I will need to encrypt, that is being encrypted in this set of keys. So this is a secret key. It is like you have the lock and you have the key. So every key has certain kind of pattern in that, so that it matches to the only particular lock that is made for that pattern. Okay. So same thing is happening here. Okay. It has the encryption key here. These are the 32-bit encryption key that I can make it. I can change it as I want, and I need to share the same key to the device that want to decrypt the message that I am sending. So this key is important. Don't leak this key. This key is important, and that need to be kept secure between you and the client device, between the sender and the client. So both share the same encryption key so that the message that is encrypted by one device will be decrypted by the other device. If this encryption key is different in the sender device and the receiver device, then the sender device, whatever the message it is encrypted, the receiver device will not able to decrypt that message because the encryption keys are different. So this need to be the same, and this need to be the securely stored between you, and this key should not be leaked out. Okay. And then there is another 16 bit of encryption key that I have added as more. So there is a 32-bit of main encryption key, then 16-bit of external encryption key to make it little bit more secure. Okay, so this is the encryption key that you need to store while flashing the device to encrypt the data, and you can change this keys pattern as per your need. You can write any other keys as well. You can create your own key, unique key. Okay, and for using the encryption key, encrypting chip and decrypting chip on this on this coin board, you need to use this library embed ls aes.h, that is for the AES encryption keys, storing and decrypting the data on the AES technology. Okay, and then md.h, that this library helps you to use the encrypting chip that is already present inside this Indus board. Okay, this Indus board. Okay, after that you need to store the keys, secret keys that you have created, unique keys. There are the hexadecimal numbers. You can store any other key as well other than hexadecimal, the binary number or some kind of ABCD EFG kind of thing. Here I am using the hexadecimal. That is the more secure way for doing the encryption, because ABCD can be directly if you encrypt the data in ABCD, that can be directly decrypted by other using the many decrypting device. Okay, by the hackers. Okay, if you convert that data, that ABCD other encryption data 1 2 3 4 5 in the hexadecimal code, then the one layer is the hexadecimal code. So it is not ABCD, it's actually the hexadecimal code, and that hexadecimal code is also unique on the sender device, and that same hexadecimal code is on the receiver device. So it will make a more secure thing. You can also use the binary thing as well, but better to use the hexadecimal code. Okay, so these are the hexadecimal code of various letters, numbers, and you can store these security keys in the that is being stored on your device. Okay, and then is another 16-bit encryption keys that I have added for the extra security layers. Okay, then what I have used here, I am using the simple thing like I am encrypting the data and decrypting the data by taking the text from the serial monitor. You can modify this code to that I will tell you later. We will make a WhatsApp kind of chatbot, chatting app that is running and hosted totally on the Quine board, and you can do the end-to-end encrypted chat like the WhatsApp. I will create that later. Okay, so here I am using the simple thing to encrypt the data using the serial monitor. So I am using the serial dot read line so that it will read out the command, what is the command there and what is the text there, and store it into the string. Okay, into the string. Okay, and then it will use the encryption keys. This key, if I have sent the command that en, that is the encrypt the keys, encrypt my data, then it will use this kind of this encrypting keys and this encrypted key that I have stored here, and using these key it will use the chip, encrypting chip inside the board to encrypt the data and then print it on the serial like this. Okay, so this is the encryption function that I have created. So if you want to send after encrypting the data, if I want to send to the other device, then you can add the sending functions here in after the encryption. Okay, after this part of the code. Okay. Okay, after that we have to create a function for the decrypt. So the same device is encrypting the data and decrypting the data, and you can use the same firmware or the other device to encrypting and decrypting the data. So if one device is just need to be encrypted, then you can remove this function and you can only use this function for the device that is decrypting the data, that is who the device that is receiving the data. Okay, so here the same device is using both thing, encryption and decryption. Like I can send the command en to encrypt the data. I can send the command to dn to decrypt the data. This is a code that I have made for encryption and decryption both thing on the same board using the encrypting key that is already integrated inside the board. Okay. So here, what we have created the decrypt function, and then it will take the input a string that we will send to the serial monitor that is being stored here, like read character, read serial dot read until there is a new line or there is a command is sent from the serial monitor. Okay, then it will store the data string, and based on the command, it will either run the encrypt function and print the encrypted message, or decrypt function, run the decrypt function and print the decrypted message. Okay, so here is the decrypted function where it will decrypt the data this AES encryption key that we have stored in the both of the device, encrypting and decrypting device. Okay, but here the both device acting as a same device. Okay, Indus coin is acting as a encrypting and decrypting both device. Okay. Okay, so it will take the hexadecimal encryption key that will be sent from the serial monitor. Okay, and then read out, and then use the internal chip. Okay, internal chip of the Indus board coin, encrypting and decrypting chip of the Indus board coin, and try to decrypt the message using the AES encryption key that we have stored here. Okay, after that. After decrypting the data, it will print out that decrypted message in the serial monitor. Okay, so now after that we will upload this code. After that we will upload this code. So for encrypting thing, you need to add this two library. Encrypting and decrypting thing, you need to add the this two library at the start of the code, and then you need to add the secret encrypting key, that is the fixed key that you need to store the 32-bit, and you can add more layer to the other 16-bit. You can remove this as well if you want. Or if you want to add more security, you can add more secret this 16-bit of data, and then you need to store the encryption keys, that unique encryption key, and you don't need to share it to anyone. This not need to be disclosed. This need to be known by only the person who are responsible for handling the this design of the device. Okay, so if this encryption key got leaked, then your data can also be get leaked. So this is the most important thing to keep it safe. Okay. Now after that, whenever I plug this code, after uploading this code, whenever I plug this code, it will initialize the these library will initialize the sorry these library will initialize the encrypting chip that is already integrated in the board, and then it will take the encryption key from the firewall that we have given from the code, and then it will ask you, and then it will run the rest part of the code, and then it will ask you to whether I want to encrypt the data or decrypt the data. I just send a en to encrypt the data. Okay, now whatever the message I want to encrypt, hello, how are you, and I type, it will encrypt the message. It will give output the encrypt the message. Okay, and then if I want to decrypt the message, I simple write dp, and then I can simply paste it, and it will decrypt the message, hello, how are you. Okay, so this decryption part, you can put it in the other device. I am using the same device for encryption and decryption. You can put it in the other device in the decryption part. So one device is encrypting the data, sending the sensor value or whatever the message you have. Other device is receiving the data and decrypting the message that whatever you have. Okay, so both thing can be in the two device as well. Here I'm using both thing on the same device. Okay, so now let's make a WhatsApp kind of thing, like where you can chat. But before that, before going to the WhatsApp kind of thing, let me tell you one more thing that we have already in, that is a true random number generator. Okay, so for any kind of security thing, like even for the creating the encryption keys, you can use the random number generator to create a true random number and create a encryption key on based on that random number. So there is no identified pattern will be visible. Because if you create your random number by your own self or using this chip or any kind of other, they run in particular pattern, and after a certain period of time there might be you find a pattern between the generating the numbers. Okay, so that pattern can be recognized by the hackers, and if you generate the encryption keys or OTP, so based on the pattern, it can it can crack the OTP. It can crack the encryption key generated by those random number. So there are a specialized chip for that. One of the most secure way is the quantum random number generation. They use the quantum technology to generate the true random number generator, and there are certain kind of specialized chip below that category. Below the quantum number random number generator is the random number generator. Okay, so they generate the random number. Like you buy the OTP, like you have already used the OTP in day-to-day life. They are generating the OTP. What are those? Those are generated by the random number generator. If it is done by some kind of program, so if any programmer has same kind of code and he know the if I can identify that pattern in the generating of that number that OTP, then I can crack the next OTP generated by that system. Okay, that can be done by the hacker. That's why we need a random number generator, a specialized chip that actually generate the random number that is not based on the code. Because in the code, there can be the pattern. Because it will generate using the own processing and own flow of code. And if I crack the flow of code and the processing, the algorithm behind the random number generating based on the codes, then it can be cracked by the hacker. Okay, that's why we need a specialized chip for generating these OTPs. That's why the company who are giving you the OTP, they either create their own OTPs or buy the OTPs from the third party. Okay, and these OTP cost a lot. Okay, for buying 1,000 to 1 lakh OTPs. Okay, because these OTPs are being created by the specialized chip, either the quantum chip random number generator or true random number generator chip, a specialized chip. Okay, so like here, you can see there is a quantum generator, quantum random number generators. This is another module that generate the random number that is not based on the program, but it can based on the hardware. The hardware generated random number, the random number generated by the hardware, not on the code. So there will be no pattern in the generation. I can't crack what is the next OTP will. So in creating of OTP or any such kind of things, these things are being used for generating the random number. So like the encryption keys that I have created. So as a human, I can create particular encryption keys by my own. But based on my usage pattern, based on my thinking, someone might crack that encryption key. Okay, that is being stored that we used earlier. So if I use a random number generator to create that encryption key, then I can add one more layer of security. Okay, so here we use the random number generator. So generally in most of the IoT device and most of the system, you need to buy this random number generator chips that can generate you the random number and give you the true OTPs to two random numbers that are not being cracked by anyone. There is no algorithm behind this. There is no program behind it, but it actually be generated by the hardware level. Okay, so for that you need to buy this kind of chips in the market. But here in the Indus board, there is already true random number generator present in this board. You now need to buy. Okay. So for other IoT device, you need to buy the random number generator chips. If that is not present, you need to buy those chips, then add those chips to create the random number. Then based on that random number, you can also either use it as the OTP or the password generators, or you can use it for creating the encryption keys that we have used earlier in the past code. Okay, but here you now need to do all those things because the random number generator chip is already there in the board. So how you can use this random number generator chip and generate your own OTPs, own password, own encryption keys by yourself? Okay, so for that, there is a library ESP random.h. Okay, this is the library that we will use. Okay, and this is the another library that help us in creating the random number generators. Okay, creating the random numbers. So using this library, we can use the chip random number generator chip inside the board and generate the OTPs or random number of this board. Okay, to activate the random number generator chip inside this board. Okay. Okay. After that, after using this library, after including this library in the code, what we will do, we will create either you can store it as a string or as an integer or a float. decimal, we will create a data types, okay, to store that particular random number generator. And then that will being stored by what this is being this is ESP random. We will create a program for that. We will create a function where it will create the random number generator. So this ESP random is the inbuilt function of this library ESP random.h. Okay, so when I call this library, when I call this function, it will in the background it will run this random ESP random dot random function that is being stored in ESP random.h that h code part. If you open that library file, okay, you will find that function there in the library. So it will run in behind this here. See, you will find the ESP random function here. So this library ESP random.h that is being already created by and given by the ESP chip. Okay, is there, and there is a function here that will use the random number generator chip inside the board and automatically generate the random number OTP for you, and then that will return the OTP if you run this function here. So what will happen, I will use this ESP random.h that is being already in the ESP SDK, and in that SDK there is a random number generator function is there that will initialize the random number chip generator chip inside the board and generate one random number OTP for you, and then uh, uh, then it will return that random number to you. Okay, so all you need to call this function ESP random.h and this library to use the random number chip that. Okay, after that, after getting the random number generated by the chip, you can print that random number on your serial monitor. Okay, on the various time interval or various kind of other things. Okay, and there is another method. This is random number generator. Okay, where it will generate the whole random number. There is a second method. That is called passive random number generator or fill the buffer. So there is a particular number, set of number like 1 2 space 3 4 space 5 6 space. So 1 2 is the number that I have created. 3 4 is the number that I have created. 5 6 number is the I have in between the space that is being filled by the random number generator. Okay. So there is a two layers of security here come. One, the random number that I have created by my own using my own brain algorithm, and then the another hardware layer of random number generator that is generated by the hardware. So there is a mixing, there is a doping of two different random numbers. So it will become more secure. It can't crack, because if you crack my thinking, my process of thought, how I generate the number, then that is not only that, there is another random number generator that is being generated by the chip at the hardware level. If you somehow have the same hardware and somehow know how that hardware is generating the random number, if you crack the next random number, then you might not know what kind of random number I have generated using my brain thought. Okay, so here you can add the both number, the human based random number generator and the hardware random number generator. So using this second method, it can fill the random number generator. So it can fill out the random number in between the set of random number that you provide. Okay, so that for that we can use this function ESP fill random number generator. So what this will do, it will take the random numbers from your with the fill in the blanks with the dash dash dash, and in between the fill in the blanks, it will use the chip random number generator inside the board and create the random number and fill out in between the space of uh, uh, your generated random number. So 1 2 3, and then that dash is being filled by the random number generated by the board, and then 5 4 6, that is my random number that I have created, and then another dash is being filled by this chip. Okay, so for that purpose I can use this. Okay, so you can either use totally random number generator that is used and created by this chip, integrated chip in the board, or I can combine the human plus chip. For combining the human plus chip, I can use the function ESP fill random number generator where it can create the random number, and there you can change the what is the size of that random number, like 32 bit, 16 bit, 4 bit, 8 bit, whatever. If I am using the 32 bit, okay. So, like earlier, I have told you that you can create an AES key. Okay, AES key for the encrypting the data. I will go to later. Let's use this. Okay, let's use it. Now I upload this code. I select the board. I upload this code. Set the setting. Set the setting and upload it. So this code, what will do, it will use this library, and within this library it will automatically run this ESP random function, and create the random number using the integrated chip inside the board, and output the random number to you. Or else, if you have given the fill in the blanks for that, then it will fill out the random number with your generated uh, you know a random number, like 1 2 dash dash 1 3 4. So in between the dash, it will print its own random number generator. Okay. So I am uploading the code. I am uploading the code. Now it will output me the random number generator that is generated by the chip inside the board. Okay. Random number generator, not based on the codes or any kind of algorithm that can be cracked. That can where you can find the pattern. There is no pattern in this. It's true random number generator. Okay. So now see, here it is generating the OTP. So in this way, you can create your own OTP or own encryption key, like you do, okay, for your own IoT security. So you can generate the OTP, you can generate the random password, you can generate many things. Okay, like you use for any kind of phone or any kind of other service, you need a OTP, and that OTP need to be generated by the chip, some hardware level that has no pattern, that has no algorithm behind it. It is totally random. It is actual random. You can't find any pattern and crack that what is the next OTP based on the pattern it has generated. There is no pattern you will find here. Every OTP is unique. See, you can't find any kind of pattern here because it is generated by the hardware. Okay. So now it is generating the OTP, okay, and I am using the random number generator that is already integrated inside the chip. You now need to buy the random number generator modules or chip like this. You don't need that. It's already there in the board. Okay. So now in the earlier encrypting data, this AES encryption key. 1 minute. AES encryption keys. These keys are created by me here. Okay. So now I can instead of creating this key by myself, one hacker can either can understand my psychology, my way of thinking, and crack this encryption key that I can might have generated these kind of encryption key because my thought process is this, like in password guessing, like suppose that generally I have certain kind of mindset. Generally I do the password of Sinha 444, something like that. I'm just giving the example, Sinha 444, and I keep this password most of the places Sinha 444. So based on my pattern, my way of thinking, might have created this encryption key based on the Sinha 44. I have created that Sinha 44 into the hexadecimal code, and you store that hexadecimal code here in the encryption key. So based on my thought process, I can have a pattern in creating the encryption key. And if someone knows my pattern, then he can decrypt the data by guessing my encryption key. Okay. So if that encryption key is created by me and stored in the encrypting of the data for the cryptography and decrypting and any hacker have known my psychology, understand how I do the thinking, and what is my thought process, and guess out what kind of password that I created, and based on that password, how I have created the encryption key. He can create a decryption key from the end user and decrypt my message. Okay, because it is generated by the human like me, and if the human have some kind of thought process, some kind of psychology, some kind of pattern in between, and this pattern can either can be recognized by the human, or using the AI it can be recognized and been cracked. Okay, so this is another security threat. So as this board has not only the encryption and decryption chip, it also has the random number generator chip. Okay, and that random number generator capable of creating true random number without any kind of using algorithm, based on totally hardware level. And also it will able to fill the random number in between the human generated random number using this function that I have told you earlier. Using this function that I have told you earlier, ESP fill random number that can fill in the blanks of random number that is already generated by the human being in between the dashes. Okay, so I can generate the new random number. I can generate the new AES keys for myself. This AES keys using the random number. So this chip can give you the AES key that is not being generated by the human, and you can use this AES key for encrypting the data and store that AES key in the chip, and then share this AES key to the other device who want to decrypt the data. So there is no human pattern in between the device that will make it more secure. So the whole this AES key will generated can be generated by this random number generator chip itself. So you not need to create the AES key by yourself. This AES key can be created using the chip, that is the hardware random number generator. So it will generate the unique key. It can store the unique key and encrypt the data and send the same decryption key to the client device and decrypt the data. In between, there is no human brain, there is no program, there is no algorithm. It is totally based on the hardware level. So it become more secure, because you can't find any kind of pattern. Be human have psychology, be human have certain kind of thought process, be human have can we have the pattern. The computer works on certain kind of algorithm and program. If that done using the software that can also have the pattern, because they use a certain kind of algorithm. But here the random number are generated by the chip, the hardware. It's not the software, there is no algorithm behind that. So that random number creates the unique key for encryption key for you, and that encryption key can encrypt your data and decrypt and share the decryption key to the end user to decrypt the data in between, though no algorithm, no human psychology, to make the device more secure. Okay, this is another way of security system. Now we need to know how we create the OTP, how we create our own security AES key that we can store and encrypt and decrypt the data. Now let's make another app like WhatsApp. Okay. So in the WhatsApp kind of thing, you might have seen the end-to-end chat, encrypted chat. You in the top you have written. You have seen it is written. Okay. End-to-end encrypted chat. So whatever the message I am sending, that is being encrypted by the application, and that encrypted message is sent to the other end user. Okay, so in between, if any hacker intercept my message, he can't read it, even if he know if he have intercepted the message. That is any kind of encrypted key like 4566788. I have sent hey hi, and he can he will intercept the message, and then message is 4566 ax by z. I can't read what he have sent it. It's totally encrypted. And the other end, the user who is receiving the message have the special decryption key that is being decrypted. So each user has its own encryption and decryption key and encrypted. So in between, if the message is been intercepted by either by the developer itself or by anybody, he can't read the message because it's the end-to-end encrypted message. So how you can create your own chat app using this device? So you can create a whole security thing end-to-end encryption decryption chip, because this board has inbuilt encryption decryption chip, It has own random number generator chip, so it can make a IoT fully secure that no other can. In this small size, it's just 3 centimeter. Okay, so now let's make such kind of chatting app, and this can host that app. Okay, so you can place this device in your home, and it will host that chat app, and anyone can join to the same network, and two-person can communicate using this device in total encrypted way. He can say hi, encrypt the message, and the other user say uh, receive the encrypted message and paste an encrypted message, and he will get the output of that. Okay, like this, like this, like this. Here, I have sent some kind of message. What I am seeing is this. This is an encrypted message. You can't see it. So how you can make this kind of chatting app, WhatsApp kind of chatting app that is being encrypted? Okay. And there is another security layer is the eFuse ID and eFuse thing that no one can change the firmware inside the device once you burn the eFuse. I will tell later what are the eFuse, what are the use of that. Today I'm talking about the software layers and hardware software combination, not the eFuse based. Okay. So let me open the chatting app. So in the chatting app, here I am using the Wi-Fi. The Wi-Fi on this board can be the AP mode or STA mode. At STA mode, it will act as a access. It will connect to your Wi-Fi network. In AP mode, it is act as an access point. It will become the hotspot itself. So I am using this device as AP mode, where it will host the web server, the web page that we have created. This is the web page that we have created. It is HTML web page for the chat. Okay. So if I copy this HTML file, this is the UI file. So if I copy this HTML page, you can get the chat app. Okay. So if I paste this code here, you will get the chat app, UI of the chat app. So this HTML code is nothing but the UI of chat app that will that will host the web page and create a UI and take the strings from the UI that we have said and send it to the device to the this board and run the functions based on the settings that we will do later. Okay. So if I run this, you will get this kind of chat app. See, you can create a more better UI, more beautiful like the WhatsApp. I am making the simple one. Okay, so it's just basic HTML, where is the background, added the button here. So, and added the JavaScript and other functions like button click. So then if button is clicked, then it will copy it will try to copy the message that I have sent and then send to the device. Then device will encrypt the message and the decrypted message will show. All these functions, the UI functions are set here. Okay. So this HTML part is nothing but the UI part. Okay. This is the application UI. So this HTML is the UI page that will be hosted, and this Indus board device act as a web server here. Okay. Okay. After that, so this is that part. Oh, before that, we will create the AES encryption key. So I can either use my own brain to create this unique encryption key to encrypt the data, or I can use the true random number generator chip inside the board and get the AES encryption key and use that encryption key to encrypt the data. That is the better way. That is more secure way. Okay. Like I told earlier. Okay. So here I was storing the 32-bit of AES encryption key, unique key that is not being shared. That is the unique encryption key that you need to keep it safe to yourself. If it get disclosed, then anyone can decrypt the data. So this is the important key. Okay. There is another 16-bit of encryption key that I have added that for the more security layers. Okay. Then here we will configure the SSID and password for the AP mode. If you are using the Wi-Fi STA mode, then you can change this password and SSID as per your Wi-Fi network in your home. Okay. And as earlier, we are using the AES.H to use the AES encryption key, encrypting chip that is inside this board. Okay, then it is acting as a web server. It is hosting this HTML UI page. Okay, so for that we are using the web server.h library to make this board as a web server, as a complete server. It's this board, this tiny little board is acting as a whole server. It is hosting the web page by on its own. So that is another interesting. This small board has the encrypting chip, decrypting chip, true random number generator, the sensors, the it can act as a server. It can also connect to the camera. Many things can be done on this board. So it's a complete board, complete IoT board. Yeah. So here on what port, every server is hosted on certain kind of port, certain number of ports. So here we are using by default, most of we use the port number 80. So on this port, it will host the web server. You can change this port as per your need. Okay. Okay, then we have a string chat history. This string data type will store the history of the chat. Whatever the message we have sent, it will store that chat. If you don't want to store the chat, it will disappear after once you send and receive. Then you can remove this part of here. I am checking keeping the history like the WhatsApp keep. So I'm using the string chat history to store the chat strings, the store the data of the chats in the device. Okay. So it has limited space of 4 to 5 MB. So it will store up to that. After that, you need to restart the device. Otherwise, you can add the SD card, other kind of storage system or cloud storage system to store the chat as well. You can integrate the Firebase and other things or AWS web services. And then we have the UI code that we have created. You can create your own UI code. Okay, to create a UI like this, or you can create more beautiful UI of chat app. Okay, like this. Okay, then in from this UI, here we have added the button. Here we have added the button and the input message. So whatever the message I have inputted, if I send that, then it will detect whether that message is what the encrypted message or decrypted message. If it is a text message, normal there is, if it detect it is a text message, not the encrypted message, then it will send me the it will run the encrypting message. It will encrypt the text message. Okay, using the encrypting function. Okay, encrypt function that we have used earlier. Okay, and if this chat UI has detected the message, it is not the encrypted message, it is not the actual message, it is the encrypted message, then it will run the decrypt message to decrypt the message. Okay, decrypt message, and return that to the UI and display it in the chat history. Here, this is the chat history. Okay, and okay, so when I upload this code, it will run on the AP mode, and it will host the web page on this IP address. When I open this IP address, the chat app will open, and I can send and receive message like WhatsApp, and it will send the encrypt and decrypt the message, and no one can read in between. So after uploading the app, you can connect the phone like this. You can connect the phone like this. Yeah, you can connect the phone like this, and you will get this kind of chat app. And when you send any kind of message, it will return you the encrypted message. And when another user, that is end user, connected on the same network, running the same using the same chat app, and when he pastes this encrypted message in his, that will return him the decrypted message. Okay, this is how the end-to-end chat encryption will work. You can use the same method to encrypt your sensor data. If you're transferring any kind of sensor data, you have a network of sensor there. Before sending the data, you can use the encrypting chip, encrypt the data, and the other chip will receive the data. After receiving the data, you can decrypt the data, and that another individual will receive. So in between, if anyone can hack your Wi-Fi network and intercept the message, he can't read the message because that is encrypted. You can use the same method. Okay, we will tell about the e-fuse, what are the e-fuse, and how you can make it more secure by not letting other one to reprogram the board, and you can lock your firmware, flash the firmware encrypt your flash as well, so that whatever the firmware that you have created, that is not being reverse engineered and decoded by the other users. How you can do all those things? There are lots of possibility on this board. There are lots of many functions on flash encryption, the EFUs, and many other things. We will cover it later. Okay. If you have any more thought, then you can ask me. And these projects are published on electronicsforyou.com. You can check the IoT encryption and decryption uh, project and all those things. You can check on the Electronics for You website. Okay. Thank you. If you have any more doubt, you can ask me in the comments. Yeah. So we have one question here from Parul Vedi. Can we rotate? Hello, I'm audible. I hope I am audible to all of you. Okay. So here I have one question from the Parul Vedi. Okay. And the question is, can we rotate the AES encryption key? Yes, you can do. You can create the code. You can rotate the encryption key from the sender and receiver. And if the what happen if the secret key got compromised? Okay. So if the secret key got compromised, somehow the secret key got disclosed, then it will be a big problem, because it can be decrypted. Message can be decrypted. Okay. So your concern is right, and but you have given the solution yourself, that you can rotate the secret key. So either you can create the n number of secret key by yourself. Okay, n number of secret key by yourself, and you can rotate in between the every time it is changing the secret key, the sender device and receiver device. Or you can use the inbuilt random number generator inside the board, and every time, for every encryption, that random number generator will generate its own secret key, and changing the secret key every time. Like every time you get the no OTP, na, in the similar way, every time it will get the new new encryption key. So every time the message will encrypted using the new key. Okay, but the problem is, you need to share the same keys for the decryption at the other end of the device. So for doing that thing, what you can do, you can combine the encrypted message and the encrypting key using some kind of secure VPN tunnel. You will transfer the new encryption key for the decryption. Or you can add some certain kind of algorithm in the device, sender device and receiver device, that will generate same encryption key every new time, and encryption and decryption will happen on the new key on the both device. Okay, you can use both things. Okay. And can we upload those remotely? Yes, you can update those remotely as well. Told you, like, you can use the algorithm kind of things. Or if other thing you can do is that changing the firmware every time. You can refresh the firmware with the new firmware for new encryption and new decryption. So you can remotely change the firmware. So firmware, it support the OTA firmware over the various platforms, Telegram, or using the Rainmaker application, or using the other methods using which you can wirelessly change the firmware as well. But firmware is a little bit of complicated, because you have to change the whole program every time for every encryption. Better to use the algorithm for creating the in, for rotating the encryption key, creating new encryption. Both device using the same algorithm, so both device will create new encryption key that is unique to both of, and both are the same, and both can rotate that after every encryption. So that can be done. Okay, thank you everyone. If you have any more question, you can ask me. I can cover that in later. Okay. Okay, thank you.